Okay, so hello and welcome to your Easy as Pie YouTube stream, and we are going to be kicking off shortly. I am just in the process of checking my stream health and my sound, and we will start at 4 o'clock on the head. So I usually like to start 5 minutes before, just testing out the rig. So the rig seems to be working nicely. I'm just going to test out the chat. I'm going to say hello, grade 12s. Welcome to Cubic Functions Practice. Okay, and I'm also going to say, please feel free to ask questions in the chat. Okay, so what I'm going to do now is, you can see my screen, but I'm going to start to open board, and I'm going to open up a specific workbook or a document that I have created. Okay, I'm just going to cancel that. Let's see. Okay, so what I've done is I have created a bit of a workbook for cubic functions, and what we're going to do is we are going to go through some of the cubic function stuff. Of course, I am going to wait until 4 p.m. on the head, but I'm hoping you can see this very well, and I'm hoping at least somebody will join, but let's see. So I'm going to give it a few more minutes, and then we will begin. And in the meantime, what you can do is you can look at the question, and we will then go through it. Excuse me, I have a little bit of a cold and a little bit of a cough. But what I'm going to do in the meantime is I'm also going to play a little bit of background music, just so that you have, while we're waiting, let's do a little bit of a stream beats. Let's play some freeware here. Well, I can see chat rate, but we have no views yet, but let's see. YouTube, and I'm going to go to stream beats. Stream beats lo-fi. Okay, so what we're going to do is we're also going to play a little bit of stream beats lo-fi. Okay, and let's just go for this. Let's pick one.
Your generosity can help me
I do apologize for the ads, but yeah. Nice and soft here, and I'm just going to see. Okay, my desktop audio is working, which is great. And we will be beginning shortly. Alright, so given that it is now almost 4 o'clock, okay, we are now going to begin with working through this question, and we're going to see how we go along. You'll notice that I put the answer and the question And let's read what we have here. I like to underline the key information. I'll underline it in a different color. But the sketch below represents the function f with the equation. Okay, f of x is equal to x cubed minus 2x squared minus 4x plus 8. Now, we should know that this is a cubic function. And remember that the cubic function or the form of a cubic function is important, right? In this case, we're given in the form ax cubed plus bx squared plus cx plus d. And recall that the a value will tell me about the shape. In this case, I know my a is 1, and because 1 is positive, I have an increasing function. So it's as x is increasing, it's going all the way to positive infinity. What else do I know? Well, the d value, in this case the constant, will tell me what the y-intercept is, and in this case the y-intercept is 8. And if I had to write it in coordinate form, I would then say it is 0 and 8. All right. Excuse me. Now, what else you'll notice is that I've got an x-intercept at A and then a double intercept at B, okay, which is important because what's going to happen is that means I'm going to have, in terms of the root form, one of the roots is going to be squared or repeated. Okay, let's see what else they tell us. They tell us the curve cuts the x-axis at A and B, right? So we know these are x-intercepts. And just B and E are turning points, so we know B is also a turning point, okay? So they say determine the coordinates of A, B, and E, right? A, B, and E. Now, the question is, what is the quickest and most efficient way to determine these coordinates, right? So you might start and go sequentially and say, let me try to work out A, and then let me try to work out B, and then let me try to work out E. Now, if that's the case, you might take longer. What I would recommend is let's look to work out the turning points first, okay? Let's look to work out the turning points first. Now, how do I work out the turning points of any graph? Okay, well, I need to find the derivative first and foremost. So I need to say, okay, what is f dashed of x? And in this case, it's going to be 3x squared minus 4x minus 4. Okay, now once I find the derivative, what do I know? At the turning point, the derivative is equal to 0. Okay, and then I equate it to 0. And then, of course, what I've got to do is I've got to factorize this somehow. Okay, so let's factorize this and see what we get. Okay, and I'm going to use the cross method in this case. I'm going to go through it nice and slow. Okay, step 1, I'm going to draw a cross, like so. Step 2, I'm going to list the factors of 3x squared on the left side. So I know that 3x times x gives me x squared. Okay. And so that's what I'm going to do next. And then I'm going to list the factors of minus 4. And I've got to do it in a way that I can get a minus 4x there, right? So what could I do? I could say, okay, maybe this can be minus 2, and maybe that can be plus 2, because I know minus 2 times plus 2 gives me negative 4. And then what I'm going to do is I'm going to cross multiply. So 2 times x gives me 2x. And minus 2 times 3x gives me negative 6x. And of course, then if I add this, negative 6x plus 2x gives me 4x, or negative 4x. So I know I'm on the right track, which means that I can factorize this to be, right? I can say f dashed of x. Or in this case, maybe let's not do it like that, but I can say 3x plus 2, okay, so this multiplied by x minus 2 is equal to 0. And so therefore I can then say x is equal to negative 2 over 3 if I equate this one to 0, or x is equal to 2 if I equate this one to 0. So what do I know? Well, you can see that this a value, well, sorry, you can see that this turning point E is on the negative side of the graph, right? So I know that the turning point E is going to be on the, on the negative side, and that has to be minus 2/3. And I know this is going to be, the point B has to be 2 and 0. Okay, 2 and 0. And that is where the double x root happens. Okay, so in this case, what I'm going to do is I'm going to work out, so for point A, I'm going to leave that for now. But for point B, what I'm going to say is I know that point B is 2 and 0. Okay, and now just to check, a way to check whether you're on the right track is if you substitute 2 into this equation, you should get 0. So let's try that. So 2 cubed is 8, minus 2 to the power 2 is 4 times 2 is 8. So 8 minus 8 is 0. Minus 4 times 2 is minus 8, plus 8 gives me 0. So I know I'm on the right track. So I know this is correct. I then work out, and I'm just going to lift this up slightly, right? I then have to work out what is f at minus 2/3. Okay, so what that means is where I see x, I plug in minus 2/3, and for the sake of speed, what I'm going to do is I'm just going to show you the model answer, because remember, you'd probably just plug that into your calculator, right? But f at minus 2/3 is 256 over 27, right? So this then becomes 256 over 27. And so remember, everyone, what's going to happen is we need to look at this and see, okay, are we expecting a positive y value? Yes, we are, because we're in the positive side of the y-axis. Okay, and then the last thing, right? So we have two of them. Okay, we've got, right, we can say we know now point E is minus 2/3 and 256 over 27. Okay, now how do we get the last one? Well, so very simply, what we could do is we could say, okay, I know that I can say, there's a few ways actually. I know that I can say f of x is equal to some x minus my root 1, and then x minus 2 all squared, right? Because remember, I've got a double root here. Okay, so how would I then work out the other one? Well, I could just use the reverse L method, right? Because I know 2 is a factor, right? So if I use the reverse L method, I'm just going to draw this for you. So step 1 is I will draw an L or a reverse L. Okay, and then what I would do is I would write out the coefficients of this graph. So 1, minus 2, minus 4, and 8. So let's do that. 1, minus 2, minus 4, 8. And then I would say, okay, I know 2 is a factor. Okay, so the first thing I'm going to do is I'm going to bring down this 1. Okay, and then I'm going to multiply. So 2 times 1 is 2. Okay, and from there, what I'm going to do, and I just want to make sure I'm on the right track here, right? Minus 2 and 0. Okay, if I have to factorize this out, what do I get? So if I add this, I just want to make sure that I'm doing the reverse L method properly, right? So if I add this, I then get 0. And no, I don't know if I'm doing this right. Okay, I'm just gonna pull out the reverse L method, so just give me a second here, please. My apologies for this. I seem to have forgotten it. I would have said 2 times 1. Just give me a second as I open up Snaplify. Okay, I'm just going to take you through the reverse L method fully. Okay, so here's my Maths handbook, which is a very, oh, this is the grade 9 one, my apologies. Let's go for the grade 12 one. Okay, let's go back there. Grade 12. Okay, so this is my grade 12. No, this is grade 10. Okay, my apologies. Let's go to the. Okay, I just need to go to the handbook here. Okay, so if I go to my textbooks and exam resources. Okay, here we go. Here's our Maths handbook. Okay, let's just go and see where we can find this. Interpretation. Okay, we need to go to the remainder and factor theorem. So that's page 132. Okay, remainder and factor theorem. Okay, so if I use the the reverse L method, I've got to drop the 1, okay, which I did. And then I've got to say 2 times 1, which is 2. Then I've got to add, so that becomes 0. 2 times 0 is 0. 0 minus minus 4 is 4. And 2 times 4 is 8. No. Sorry, 0 plus, that's minus 4, that becomes minus 8, and then that becomes 0. So I know I'm on the right track here because I've got a 0 here. So what I have here is I then have x squared minus 4. Okay, which makes sense. Okay, which means I was on the right track in the first place, but I can then say that f of x is equal to, and remember x squared minus 4 can be written as x plus 2 into x minus 2. And then I know I also have an x minus 2. Okay, so this is how this then becomes x minus 2 all squared into x plus 2. Okay, so my other root is then, the point A is then negative 2 and 0. Okay, and that's how I get this. And this is how I would have gotten part A. Okay, my apologies. Usually I don't get a 0 here, so that's maybe what confused me. But pretty much you can see how we've done it. And so now we have the coordinates, and what I'm going to do is I'm just going to write down these coordinates here. So I know this is minus 2 and 0. And then this part E here, just going to write it here. That's going to be minus 2/3 because we need this information for later. And 256 all over 27. Okay, so now that we have this, let's just erase this and see what we can do for the next part of the question. Okay, I'm gonna erase this. And before we move on to the next part of the question, what I would like to do is I would like to show you the model. Right, so you can see that in this case, well, they factorized first and they got minus 2, 0 and 2, 0. Okay, and then they found the derivative and they got point E. How you do it doesn't really matter. You can do it in any order, but that would have been 7 marks. And let's underline what they're asking for next. So then they say determine the x coordinates, right, of the point F, which is the point of the inflection of f of x. Now remember, whenever they are talking about point of inflection, okay, what do we need to work out? We need to work out f double dashed. Now we had already worked out f dashed, and we knew that f dashed was 3x squared minus 4x minus 4. And then we need to work out f double dashed. That becomes 6x minus 4. And then I need to equate it to 0, because that's where the poi, or the point of inflection, is. I'm then going to solve, so I get 6x is equal to 4, and then x is equal to 4 over 6, which is 2/3, right? Now they only want the x coordinates, so your answer in this case will be for f, okay, 2/3, and let's have a look at our answer. So you can see how I got 2/3, you can see what they've done. Exactly the same that we have done. Okay, so that's the point of inflection, so we know that's 2/3 and something. Okay, and then from here, if we go through it, right, then they say, and this is a 6-mark question, so this is a big one. They want you to determine, right? They say the straight line, and I'm going to do this in yellow. They say the straight line g with the equation g of x is 3x plus c is tangent to f at d. Determine the coordinates of g. All right, now if we just drew, and well, you can see they've drawn it already, right? They've drawn this already. Okay, now we know that this graph here has the equation y is equal to 3x plus c. Now the key thing here is we know the gradient. Okay, so the first thing we can do is we can work out the point of intersection of the two graphs at D. And how would we do that? Well, what we would do is we would say, okay, what is the derivative? Well, we know it's 3x squared minus 4x minus 4. And at the point D, it has a gradient of 3. Okay, so remember, derivative tells us the gradient at every point. And we know that the gradient is 3 at the point D, and we need to get the x value, right? So what I will do is I'll turn this in a quadratic. I then get 3x squared minus 4x. I take the minus 3 minus 4 is minus 7 is equal to 0. Okay. And then, of course, I've got to factorize this. Okay. Similar story. Well, what I will do is I will use the cross method. So I'm just going to draw a cross on the side here. And this is just to explain it for you. But on the one side, I get the factors of 3x squared, so 3x and x. And then on the other side, I get the factors of negative 7. So I'm going to try negative 7 and plus 1. Okay, and of course, if I do the cross multiplication, I get minus 7x, and I get plus 3x. And of course, if I add this, I get minus 4x. So I know I'm on the correct path. And so I factorize to be 3x minus 7 and x plus 1, which is this one, which is equal to 0. Now in this case, I then get x is equal to 7 over 3, or x is equal to minus 1. Now what does this mean? That means that, well, this point D, that has to be minus 1. Okay, that has to be minus 1. Right? And so what we can do is, if we know D has an x value of minus 1, what I can then say is, okay, let me work out f at minus 1. Remember, it has to be minus 1 because I'm on the negative side of the graph. This 7/3 corresponds to a parallel line that's tangent to the graph somewhere else. Okay? And so in this case, what's going to happen is I just plug that in. So minus 1 cubed is minus 1. Minus 1 squared is 1 times 2. Minus 2 is minus 2. So minus 1 minus 2 is minus 3. Minus 3 plus 4 is 1. And 1 plus 8 is 9. Okay, so I now have the point D, which is negative 1 and 9. And of course, I have the equation of this line, and I can plug in this point, right? So I can say, okay, I know y is equal to 3x plus c, and I can plug in the point D. So I'll say 9 is equal to 3 times minus 1 plus c, and I then get c is equal to 12, okay? And of course they want the coordinates of g, right, which is the x-intercept. So we know we can say that y is equal to 3x plus 12. And then what do I get, or how do I get the x-intercept? I let y equal to 0. I then get 3x is equal to negative 12. And therefore x is equal to negative 4. And so therefore my point G must be negative 4 and 0. All right. And if I look at the answer here, I get negative 4 and 0. So this is the answer. And this is the full question. So you'll notice it wasn't too difficult. A lot of working out, yes. Difficult, not particularly, as long as you can fully understand what they are asking you for. So that's the end of this question. It's taken us about 21 minutes. And I hope this has been of benefit to you, and we're going to call it here. Right, nice and short and sweet. But I will see you then next week. We will be working through maybe rates of change and optimization. Okay, see you next week. Ciao.